Hello students, so today we will talk about vectors. So it's a chapter, very interesting chapter of class 12th, and it's very important in JEE, JEE Advanced as well as your board exams. Alright, so it consists of two chapters. First we will study about vectors and then we will study about 3D geometry. Till now we have studied about geometry, then straight line, coordinate geometry, then we have understood about parabola, ellipse, alright. But from today onward, we will study about 3D spaces. How can, what is a vector first of all, and how it is different from other quantities. Alright. So vectors are, very important topic, not for your JEE exam, but as well as in further studies, higher studies, in engineering, right? So if you see robotics, it's a huge application in robotics. And if you have played any games, video games, especially computer games, like when you fire someone with a bullet in a game, the vector starting from a gun point to the pixel of enemy head, that thing is a vector. So it consists of it's a very complex calculation is required in making games using those vectors. But vector as a concept is very simple. मैं बार बार बोलता हूँ कि it's a very low input and higher output chapter. So if you have studied straight line very good, आपको सब कुछ चीजें याद है उसमें, तो it's a very easy chapter for you. The things that will apply in 3D geometry and this vector chapter will gonna be very easy. So let's start this chapter, and it's one of my favorite chapter. So it's a very easy chapter. So what is a vector first of all? So all the things in this universe, this world, can be categorized into two categories. The first one is the scalar quantities, something which has only magnitude, not any direction. All right. And the second category we call as vector quantities. So what is vector? Vector is those quantities which has magnitude as well as direction associated with it. We have already studied in this your 11th class, motion in 1D physics class. Alright, we have already studied about what is vector quantity. But in this mathematics, we will deep dive into vectors. We will study about what are real laws, how can you add separate vectors, and how can you multiply two vectors, algebra associated with vectors. And in the next chapter, 3D geometry, we will study about how do you, locate a vector in 3D space. So, suppose this is a wall, this is a plane of wall, and this is the origin, alright? So this is xy plane. So this is x-axis, this is y-axis. So this is x-axis, this is y-axis. Suppose I have these two clusters. This is x, this is y, and this is xy plane. But if I suppose another straight line, I draw another straight line like a z-axis. So this is xy plane, this is z-axis. All right. So in 3D space, if I place a point, so I need to find the position of this point. And to find the position of this point, we can use the coordinates as well as we can define the coordinates and as well as we can define the vector associated with it. So what is a vector first of all? Vectors are those quantities which has magnitude as well as direction. Alright, such as, if I say I am moving at 64 km per hour, alright, but you will ask me another question, in what direction? In north, in east, in south, in what direction? Alright. But in the case of, if I ask you, the time today is 6:45 p.m. But you will not ask, sir, in south, in north, in upward, in left, in which direction time is 6:45 p.m. This is universal. It doesn't depend on the direction. But in the case of velocity, it depends on direction. Similarly, in the case of force, if I apply 5 Newton force, but where? The next question arises, where? So that's why it is a vector quantity. Vector has a magnitude as well as direction. So first of all, write down vector and scalar quantities. Vector and scalar quantities. Alright. So write down the definition of scalar quantities. First, scalar quantities. Write down the quantities which are associated, the quantities which are associated with only magnitude, the quantities which are associated with only magnitude, are called as scalar quantities. For example, if I say I am 22 kilogram, I have a packet of 22 kilogram. So its mass is constant throughout any direction. But if I suppose call as if I talk about weight, what is the weight? You have studied in physics. What is the weight? Weight is a force, a type of force, a gravitational force. Right? Weight is always downwards. Weight is defined as mass into g. G is gravitational constant. So weight is a vector quantity. All right, but mass is a constant. Something has a mass. If the marker has a mass, it is constant throughout any direction. It doesn't change in north, east, upward, leftward. All right. So mass is a constant. It's a scalar quantity. Similarly, if I talk about temperature. So, but temperature changes in hilly areas like Himachal Pradesh, or when you go downward south, the temperature increases. Yes, but it doesn't depend on direction. It is a heat map of a particular area. But in a particular area, a particular heat map of that area, the temperature throughout that heat map is constant. Suppose in this room, the temperature at every single point is constant. Or if I talk about this city, Kota, temperature is constant. Alright, it doesn't depend on direction. Like if I move leftward, the temperature doesn't change. If I move rightward, the temperature doesn't change. That's why it's a scalar quantity. Similarly, if I talk about volume is also a scalar quantity. Alright. So let's talk about what are vector quantities. Vector quantities. Write down the definition of vector quantities. The quantities which has magnitude, the quantities which has magnitude as well as direction are called as vector quantities. All right. For example, if I talk about velocity is a vector quantity. All right. If I talk about acceleration, it's also a vector quantity. Displacement, you have all those things you have studied in your physics class. All right. Velocity, acceleration, these are vector quantities. All right. So everything clear about scalar and vector quantities? Any doubt regarding it? Okay. So let's talk about how to represent a vector quantity. How do we represent a scalar quantity? How do we represent a mass? We represent a mass by its magnitude and its unit. All right, like 4,000 Kelvin, 40 degrees Celsius. All right, magnitude and the unit of that quantity. But in case of vector quantities, you have to define three things. First one is magnitude. The second one is direction. And the third one is unit. Alright. So right now, representation of vectors. Representation of vectors. Alright. So how do you represent a vector? Right now, a vector is represented as a vector is represented by directed line segment. Alright, a vector is represented by a directed line segment. So what is directed line segment? So just look at the word directed line segment. What is a line segment? A line segment is a part of a long, never-ending line. There is a never-ending line, and line segment is a small part of it. Alright. When I give direction to the part, there is a line segment, and when I give direction to that line segment, this is called as directed line segment. Alright. That is the definition of directed line segment. Write down definition of directed line segment. A portion of line having two endpoints. A portion of line having two endpoints. VIZ. What is VIZ? Namely, or that is a portion of line having two endpoints. VIZ, initial point and terminal point. Initial point and terminal point. Initial point and terminal point. It's called as directed line segment. Alright. आगे लिखिए. A DLS. What is DLS? Directed line segment. A DLS with A as initial point. A DLS with A as initial point and B as terminal point. A DLS with A as initial point and B as a terminal point can be written as AB vector or this AB के ऊपर एक arrow बनाना. So a DLS with A as initial point and B as a terminal point can be written as AB vector. How do you call it? AB vector. Vector is a line. इसके ऊपर line है. Alright. So how do you represent it? Suppose there is a vector AB. There is a 2 point A and B, and the direction of that AB as A from A to B. A से B जा रहा है. The sense of this vector is like this. Alright. What is B? B is a terminal point, the ending point or tip point. What is A? A is starting point or initial point. Alright. So this AB vector lies on an infinite length. This AB vector lies on an infinite length of line. The infinite length of line is called as support of line. Alright. This infinite length जो है This is called support. Alright, this is called as support, of which this line segment may be, or a DLS is a part. So infinite length of the line is called support, and the DLS is a small part of it. Alright, and we call DLS as a vector area. Alright. So this length is called as magnitude of AB. So the length AB is called the magnitude of vector AB. How do you represent the magnitude? By two bars like this. Alright. How do you represent the line? This is length of AB. This is vector AB. This is magnitude of it. This is called magnitude. Alright. Alright, understood? This length is called magnitude of AB. Okay. This is line of support. Line of support. Alright. Let's move ahead. So the direction of AB is from A to B. What if the direction is from B to A? Like this. This is A point, this is B point. How do you represent this? This can be represented as BA vector. The first letter is the initial letter, initial point. The last letter, the second letter is the final point, the terminal point. In this case, this is terminal point. Alright, this is initial point. And you can represent this as BA vector. Got it? समझ में आया सबको? Alright. So write on the note. Write down some 2 points in the note. Write down the vector AB. The vector AB. The vector AB. How do you write the vector AB? This. You don't have to write B, C, T or vector. Just write vector AB. Vector AB and vector BA. Vector AB and vector BA are different. Vector AB and vector BA are different because the sense of direction are different. The sense of direction is different. Vector AB and vector BA are different because the sense of direction is different. Right on second point. Magnitude of any vector. Magnitude of any vector is always a non-negative real number. Is always a non-negative real number. Vector of any magnitude of a vector is always a non-negative real number. Alright, you can also write as vector AB for vector AB. The magnitude of a vector is always greater than or equal to 0 or non-negative. Alright, let's move ahead. So, further, the question arises, sir, this is a vector and this is how we present a vector. So how many types of vector are there? So write down types of vector, types of vectors. All right. The first one is zero or null vector. Zero or null vector. Write down. A vector whose magnitude is zero. A vector whose magnitude is zero is called as zero vector. It's very understood, very intuitive that a zero vector has a magnitude of zero. सभी लिखिए, आगे लिखिए. It is represented as zero vector, zero के ऊपर vector, zero vector or simply zero. It is represented as zero vector or simply zero. आगे लिखिए. Its direction is arbitrary. Its direction is arbitrary. What is arbitrary? Not defined. We don't know the direction of it. It can be anything. Its direction is arbitrary or not defined, or it can be anything. All right. Okay. Let's move ahead. The second type of vector, very important. Unit vector. What is a unit vector? It's also introduced by the name. Write down. A vector having a magnitude of 1. A vector having a magnitude of 1 or unity is called as unit vector. It's called as unit vector. A vector having a magnitude of unity or 1 is called as unit vector. Got it? समझ में आया सबको? आगे लिखिए. A unit vector in direction of vector A. A unit vector in direction of vector A is called as a unit vector in direction of vector A. Vector A के डायरेक्शन में unit vector है. उसको क्या बोलेंगे? A के ऊपर एक टोपी सी. Unit vector in direction of vector A is called as A cap. A के ऊपर एक टोपी, a cap, a small cap. How do you read it? A cap. Whenever you see a vector having a cap or a cap on it, that means the magnitude of that vector is 1. It's a unit vector. All right. So A cap, the magnitude of A cap is 1. All right. So there is a cap can also be written as the vector A upon magnitude of vector, or the vector itself, or magnitude of vector. Got it? So any vector in the direction of a particular vector, if you want to find out an unit vector in the direction of a given particular vector, how do you write it? First of all, you write a vector and you divide it by its magnitude. The thing you will get is unit vector in direction of A vector. Got it? सही में मैंने आपको क्या लिखा है? सही में मैंने आपको लिखाई थी कि unit vector in direction of A is called as A cap. ठीक है, A cap का मैग्नीट्यूड क्या होगा? The magnitude of A cap is unity. All right. And you can also write the A cap as A vector upon magnitude of A vector. The vector upon its magnitude is the thing you will get it the unit vector. All right. You can also write it as corollary. What is corollary? As follows. It can be defined as the A vector can be written as magnitude of A vector into A cap. What is A cap? A cap is the unit vector direction of A. So these two formulas are very useful. All right, got it? Okay, let's move ahead. Write on the note. Write on the note. A unit vector in direction of a unit vector. A unit vector along x-axis, a unit vector along x-axis, y-axis, y-axis, and z-axis. A unit vector along x-axis, y-axis, and z-axis are defined as, are denoted as I cap, comma, J cap, and K cap respectively. Alright. So for x-axis, a unit vector along x-axis is called as I cap. A unit vector along y-axis is called as J cap. And a unit vector along z-axis is called as K cap. Suppose this is x-axis, this is y-axis, and this is z-axis. So outside of the board. Alright. So a unit vector along x-axis is called as I cap. A unit vector along y-axis is called as J cap. And similarly, z cap along K cap. Alright. Yani the magnitude of I cap is equal to the magnitude of J cap is equal to the magnitude of K cap. Kitna hoga? Yes, the magnitude is 1 because it's a unit vector along x, y, and z. Alright. Next one. The third type of vectors that we will discuss is collinear, or they are also called as parallel vectors. Alright, write down. Vectors are said to be collinear. Vectors are said to be collinear if their DLS are parallel. What is DLS? Directed line segment. So vectors are said to be collinear if their DLS are parallel, irrespective of their sense. Bracket में लिखिए direction. What is the sense? Sense of direction. Like a sense A to B, a sense B to A. It's denoted as direction. So vectors are collinear if their DNS are parallel irrespective of the direction associated with it. So what does that mean? It simply means that if I have given two vectors, if they are parallel to each other, alright, if they are parallel to each other and if they have same direction and if they doesn't have same, it doesn't depend on direction. If they are parallel, they are bound to be collinear, alright. Like these, let's suppose these two are vectors, these are two parallel and these are tending upwards, alright. These two are parallels. But if I take these two vectors, are these parallel vectors? No. These are not collinear vectors, but these are collinear. The direction of these vectors are upward. But if I change this as niche, the marker is tending downwards and the duster is tending upward. Are these collinear? Yes. These are also collinear. Okay. So the collinear vectors are of two types. If the direction is similar in the same sense, these are called as like vectors. Like they are liking each other. If the direction is not similar, the direction is not similar, those are called as unlike vectors. All right. So let's suppose these two vectors are parallel. All right, these two vectors are parallel. These are called as like vectors. But if I talk about this, these two are also collinear vectors, but the thing is they are called as unlike vectors. Why they are called as unlike vectors? Because the direction are not same. The angle between these two vectors are 180 degree, or you can simply call it as like this. These are also called as anti-parallel vectors. Why anti? Because they are parallel, but the direction are opposite. All right. Let's move. Okay. So write a note for it. Write a note. Note लिखिए. If A and B are parallel vectors, A and B, vector A and vector B are parallel vectors, then vector A can be written as lambda times vector B. Very important. JEX के लिए बहुत important चीज है. If vector A and vector B are parallel vectors or collinear vectors, then those two can be written as A vector is equal to lambda times vector B, or you can also write it as B vector is equal to lambda times vector A. It doesn't matter. What is lambda, sir? Lambda here is some constant, all right, or a real number. Okay. So tell me, if my lambda is positive, what does that mean? What does that indicates? For a hint, if lambda is greater than 0, is positive, is it like vectors or unlike vectors? Sorry. बताइए. Yes, the vectors are like vectors. Clearly, if lambda is negative, it will be unlike vectors. All right. समझ में आया सबको? All right. Let's move ahead and talk about positioning vectors. Very important. do you define the position of a point? First, if suppose there are 3D coordinates are given, x, y, and z. X, the y, this room of and the z. And just suppose a point, and this is that is origin. For this point, what are the coordinates? It's going to be x, y, and z. But how do you define a vector from origin and to this point? How do you define it? How do you define the position of that vector? So write down the heading. Position vectors. Alright. First of all, we will talk about of a point. We will first find out the position vector of a point. Then we will talk about the position vector of a given vector. Let us suppose, first of all, we will talk about a point. There is a point P in the space, and that is origin. How do you define a vector arising from an origin and to this point? The P point is terminal point, and that O point is initial point. How do you define a vector? Alright, then we will talk about, there is a given vector AB. AB is a given vector. How do you define the position of this vector? Then we will talk about this. Alright. So first of all, we will talk about of a given point. Alright. Suppose this is a xy axis. This is z axis. This is x. This is y. Alright. Alright, can you imagine this? There is a P point in the space. There is a Q I made, and there is a P point in the space. The origin is there. You can imagine it from a room. Alright, and I want to find out the position vector OP. What is the OP vector? I want to find the OP vector. Alright, let's find it. So write down, let O be a fixed point, let O be a fixed point called as origin, let O be a fixed point called as origin, and P be any point, and P be any point, and P be any point in space, then the OP vector, is called as position vector of P with respect to O. Yani OP is what? OP is a position vector of P with respect to origin. Alright. Let us suppose I call the OP vector as small p vector. Alright. Then I can write the OP vector as small p vector. Okay. I can write OP as a small variable p vector, and I can write it like that. Alright. Write down again here the position of P is given by orthogonal triad. What is orthogonal? First of all, what is ortho? Something which is perpendicular. Alright. What is gono? Gono means sides. Alright. So why do we call it as orthogonal triad? The position of P. This is P, and this is x comma y comma z. Alright. This is called as orthogonal triad. Why do we call it as orthogonal triad? X comma y comma z. Because orthogonal is perpendicular sides. Triad triplet. Its position is x comma y comma z. The position of P can be defined as x comma y comma z, or you can call it as coordinates of P. Coordinates of P. Alright. Orthogonal means perpendicular. Perpendicular. Got it? Alright. What is the position vector of P? The position vector of P is called P vector, small p vector. Alright. So tell me, what is in this diagram, in this coordinate? What is xy plane? What is xy plane? This plane is xy plane. Alright. What is yz plane? This plane. The left hand side plane is yz plane. And what is zx plane? The one in the bottom is zx plane. That is the bottom of my room. Alright. So to reach at P, how to reach at P? First I will go x distance at x in the x direction. Then I will go in y distance in the y axis. Then I will come in front of the board in the z axis in z direction. So my x is in this x comma y comma z orthogonal triad. What does x represent? X represent is distance from. What is x? X is this length. X is this length. What is y? Y is this length. Y is this length. What is z? Z is this length. Alright. What do we call x as? Distance from yz plane. What is x? X is distance from yz plane. And what is small y? Small y is distance from zx plane. Distance from zx plane. Similarly, z will be called as distance from xz plane. Alright, सबको समझ में आ गया x y z क्या है? These are orthogonal triads. These are also called as coordinates of point P. And what is the position vector of point P? It is small p. In the next class, we will study about how do you take the components of point P in x, y, z direction. Alright. So next class में हम पढ़ेंगे कि इस point P का कैसे हम components लेते हैं. And then we will study about the position vector of the vector given here. Alright. So आज के लिए इतना ही. Thank you for the class.